Today we're going to look at adding and subtracting rational expressions, and we're going to start with adding and subtracting when I have like denominators. So you might remember when I was adding and subtracting regular fractions, you would have to have a common denominator. So I could add something like this and get 3/4, but if I had, say, 1 over 5 and 3 over 4, I would need to get a common denominator, in that case 20. It's the same idea when we're dealing with fractions that have variable expressions. So I always need to check if I have a common denominator. In this first problem, we do, so I can just add the numerators. You want to pay attention to what sign you have here. When it's addition, we don't really need to worry very much, but when it's subtraction, we need to be careful. So I get x plus 8 over x minus 5, and that's not going to simplify any further because my numerator does not factor. So looking at the next one, I'm not going to multiply out the bottom because it'll be helpful in the next step if I do not do that. So we're going to do x squared plus 3x minus 2 plus 4x plus 12 all over my common denominator of x plus 5, x minus 2. So that's going to give me x squared plus 7x plus 10 over x plus 5, x minus 2. The last step is really important, which is, does the numerator factor? My first problem, it didn't, so I could just stop the problem. But in this problem, my numerator does factor. I know that it factors because if I check with the x, do I have two things that multiply to 10 and add to 7? Yep, 5 and 2. So that gives me x plus 5, x plus 2, over my denominator x plus 5, x minus 2. And now I have a common factor that I can reduce to 1, which gives me a final answer of x plus 2 over x minus 2. Now we get to a subtraction problem, and this is where you want to be really careful and specifically be putting parentheses around your second numerator so you don't forget to distribute. So x squared minus 2x plus 3 minus parentheses x squared minus 4x minus 5. And I'm going to simplify the numerator a little bit before I put it over the denominator just to save some space. So I can distribute that negative. I'm just going to bring down my first numerator, and this is going to switch all my signs. Minus x squared plus 4x plus 5. So my x squared terms are going to reduce, and then I'm going to get 2x plus 8 over x squared plus 7x plus 12. I noticed that I have a GCF in the numerator, so I'm going to factor that and see if I can cancel anything with the bottom. So I get 2 times x plus 4, and now let's see, two things that multiply to 12 and add to 7 are 4 and 3, and I do in fact have a common factor in the top and bottom that I can now reduce to 1. So I'm left with, for my final answer, 2 over x plus 3. Now we have on the back some larger problems, but we're going to treat them the same. Don't forget about your parentheses that you really have around these numerators. So like on the front, since I have a common denominator, I'm going to simplify my numerator just a little bit to save some space. But really, this is all over my denominator. So x squared plus 5x plus 1 minus 4x plus 5 plus 7x plus 9. So let's see, x squared, no other x squareds. I have 5x minus 4x is x, plus 7x is 8x. And then I have negative 1 plus 5 is 4, plus 9 is 13. And I know I'm going to be done with this problem because there's nothing that multiplies to 13 and adds to 8, so I'm totally finished. Next we have a simple addition problem with a common denominator. So I get 5x plus 15 over x squared minus 9. I notice in the top I have a GCF, so I'm going to factor that out. 5 times x plus 3 over x plus 3 x minus 3, difference of squares. And in fact, I do have a common factor that I can reduce to 1, which gives me a final answer of 5 over x minus 3. So what happens when I don't have a common denominator? We talked about an example problem on the first slide. These are maybe different numbers, but it's the same idea. When I had something like this, you would need to multiply and get a common denominator. So in this first fraction, I would multiply by 5 over 5, because 5 over 5 is just a special type of 1. 5 over 5 reduces to 1. In the second fraction, I would multiply by 3 over 3. And I would get 10 over 15 plus 12 over 15, and combine that to get 22 over 15. We're going to use that same exact idea to get a common denominator when I have variables involved. In order to do that, we need to make sure the denominator is factored, which the first few already have that done. So we'll start kind of simply with these two little fractions. So I always start with the first fraction. This one has a 5 in the denominator, but this one doesn't, so we're going to multiply by 5. But if I multiply the bottom by 5, I have to multiply the top by 5. Now I look, and the second fraction has a bottom of y, which the first does not. So I need to multiply by y over y, because y over y equals 1. So now I'm going to clean this up a little bit. 1 times y is just y, plus 1 times 5 is 5, over my common denominator of 5y. And that's my final answer. Looking at this next one, here's something that's tempting. You want to think about, if I just have a binomial or something in the denominator, you want to think like there are parentheses around there. So like, I'm not going to get to the minus 3 by like minusing 8 or something to this fraction. It's all one unit together right there. So looking at the first fraction, I have x plus 5 in the denominator. So that means I need to multiply my second fraction by x plus 5. But my second fraction has x minus 3 and my first doesn't, so I'm going to multiply by x minus 3 over x minus 3. When I have something multiplied to its, or divided to itself, then it's just going to reduce to 1, and I can multiply anything my heart desires by 1. So rewriting my numerator a little bit, I get x times x minus 3 minus 2 times x plus 5. Like I did on the previous page, I'm going to simplify my numerator a little bit, but really this is all over my denominator. So I get x squared minus 3x minus 2x minus 10. So my numerator is going to be x squared minus 5x minus 10 over parentheses x minus 3 x plus 5. Now we do want to check, see if our numerator factors. Is there something that multiplies to negative 10 and adds to negative 5? I only have 10 and 1 and 2 and 5, so that's not going to work. And my problem is totally done. I want you to take a second and look at this next problem and tell me what you notice. I notice that I have the same two terms and subtraction, but they're in reverse order. So what I can do is actually just multiply one of my fractions, and I'm going to choose this one, by negative 1 over negative 1. Because negative 1 over negative 1 is just positive 1. So it's something I can do. And just to show you what's happening, you don't need to write this. Here's what happens when I multiply this term. I would get negative 4 plus x, which I could rewrite as x minus 4. So this is going to get me to having my common denominator. So I would have 5 over x minus 4, and then I have minus a negative 3 over x minus 4. Well, what is minus a negative really? But just adding. So I get 8 over x minus 4. So this is a really handy thing to be able to do anytime I have that same two terms and subtraction, but they're just in kind of the wrong order, if you will. Obviously we have a little bit of a boo-boo on the next one, and we don't have what operation is written. So how about we choose to do subtraction? Okay, so if you can add some subtraction on there. So put your little parentheses around your denominator. There's nothing I need to factor with that. And I don't have an x plus 7 in the right, so I'm going to multiply by x plus 7 over x plus 7. And then I have an x minus 5 over x minus 5, because I do not have an x minus 5 factor. Please don't call this cross multiplying. It actually isn't cross multiplying, and sometimes we aren't going to need to be multiplying by everything in the other denominator, so please don't call it cross multiplying. Thank you. Alright, distribute. So 4x minus 20 minus 3x minus 21, and I get x minus 41 over my common denominator of x minus 5, x plus 7. Definitely nothing that is going to cancel there. Let's look at a few more examples. So once again, put your parentheses around your denominator. It will help you focus. So I do not have a single factor of a in this left problem, so I'm going to multiply by a over a. And then the right one does not have an a minus 3, so I'm going to multiply by a minus 3 over a minus 3. So that gives me 3a minus 2 times a minus 3. I know someone wants to do all this stuff in their head, but my caution would be to be really careful about that when you are dealing with negatives. Just be careful. So I get that all, once I distribute and combine like terms, is a plus 6 over my denominator of a times a minus 3. Very similar problem for the next one. Multiply by y over y, and then, whoops, y plus 2, y plus 2. So 5y minus 3 times y plus 2. So 5y minus 3y, not x, minus 6. So 2y minus 6 over y times y plus 2. Now I see my numerator factors, it has a GCF, but when I try, it doesn't reduce at all, so I could leave either 2 parentheses y minus 3 in the top, or just leave it how I had it. And the more we do, the better you'll get at seeing whether there's a chance that it's going to be something that simplifies a little bit more. Alright, 2 more questions. These ones are a little bit different because we have some quadratics going on in our numerator. So if you notice in the first problem, I have that situation we had on the front where they were the same thing but in a different order. So I'm going to multiply by negative 1 over negative 1. So I get x squared. That negative 1 is just going to flip my signs over x minus 5. Let's see if that numerator factors. Multiplies to negative 10, adds to negative 3. That's negative 5 and negative 2. So I get x minus 5 times x minus 2 over x minus 5. So I do in fact have a common factor, which means my final answer reduces to x minus 2. Last one. You can't believe it, can you? Alright, so I'm going to multiply my first one by w minus 2 over w minus 2. Need a little room. Second fraction, I'm going to multiply by w minus 7 over w minus 7. So I am going to distribute this in one step. 2w squared minus 4w plus w squared minus 7w. And I did that, I felt comfortable doing that because I had an addition in between, so I'm not worried about signs. If there's subtraction, I generally try to be careful. So 3w squared minus 11w over w minus 2 times w minus 7. Now there is a GCF in the top, but think about taking out a w. Is that going to allow anything to cancel? No, so we're good.